How's it going, everyone? Vlad here with SolusPLC.com. In the last tutorial on Allen Bradley PLC programming using Factory I/O, we've talked about how we can detect a difference between a wide and a narrow box. And we've created a station that does exactly that. And then in our PLC program identifies the box and sets a counter on the PLC side, which we've then displayed in Factory I/O. Today, we're going to take this a little bit further and we're going to implement a reject system or a divider system that splits both of types of boxes into two streams, so one for the narrow boxes and one for the wide boxes. Now, there's going to be a lot of challenges in this example. We're going to be using a FIFO just to reveal what's going to be the nature of this video. It is an instruction that is fairly misunderstood in PLC programming, so there's definitely going to be a lot to discuss, a lot to implement on the PLC side. So without any further delay, let's get started. So what I would like to do with these series is to give you a little bit of a demonstration before we dive into the example, and I also want to explain what are some of the challenges that you will see on the real production floor when it comes to this application. So here, what I'm going to do is I'm going to enable the system, and you'll notice that the same boxes that we've seen last time are going to start rolling on the conveyor belt. And once they reach the divider, or essentially both streams, one of which being the ramp and the other one just a simple chute, they will be diverted depending on their size. So you'll see that the smaller boxes are going to continue straight. Again, in a production environment, this would be a conveyor belt, maybe to a different warehouse or a different location. And if they are of the large size, they will be sent down the chute right here. I've added a couple of elements that we will discuss in Factory I/O as well, but I want you to pay attention to the example that I'm showing here, and all we're doing is sorting the boxes from narrow and wide, and in this specific case, it looks like we're getting a lot of these narrow boxes in a row. Again, this is randomized by the program, so we're just going to have to watch until a larger box shows up. And all of the logic that is created is derived from the application we built last time. So if you are watching this video as an introduction, I suggest that you click on the link right now on your screen, watch the previous video to see how we've created the counter, because we're going to be expanding on that PLC logic to create this specific scenario. And if you want to attempt this on your own, very easy to replicate. You can download all the files on GitHub, and let's dive into the application. So before we start programming, what are some of the challenges in this specific scenario, and why is this a very important PLC programming or manufacturing challenge? Well, a lot of times you will not have a scenario where you're able to detect what type of product this is and be able to divert that into different streams. A lot of times what happens is that you create a product. So for example, this could be a registry on your case packer, and then your palletizer is in a different location in your plant. So you're going to merge a lot of those boxes on a single conveyor. You need to keep track of what type of boxes these are in an array, which is what we're going to be using to solve this problem. And then at the end of that conveyor, you will want to send them into different directions. So all that to be said, it's going to be rare where you can detect the type of box and then you can move it to one side or the other immediately there. A lot of times this is going to happen downstream, just as illustrated in this specific example. And so what is the problem in that case? Well, if you have a sensor located exactly at the split, you can use a timer. So for example, if you detect that this box is a wide box, you can simply trigger this pivot arm in, let's say, 100 or 200 milliseconds, and then turn it back after, let's say, 2 seconds have passed, because you can tell reliably that the box has transitioned into the second stream. But in this case, you can't use timers, right? You don't know what's going to happen between the first photo eyes and the last photo eyes. You don't know if this conveyor is going fast or if it's going slow. So what you're relying on is an array on the PLC that's going to store that value throughout the program. And then once the box reaches the split, it's going to pull off that value from the array and be able to divert it to the appropriate location. So a couple of new elements that we want to introduce in this episode. So the first one being this pivot arm. If I play the animation, I can select the pivot arm and I can press to toggle the conveyor belt that's on the arm itself. That conveyor is going to allow the boxes to essentially go through faster. What I found is that you just can leave it enabled. There's no need to tie this back to the PLC. And the important part is going to be the turn. So if I toggle this turn signal, you will notice that I can divert the boxes, in this case, directly on the production floor. But in reality, we're going to control it with the PLC to know where to send the box downstream. So essentially, this pivot arm has a couple of signals, which is the conveyor belt on it as well as the pivot, but we're only going to tie in the pivot. We're going to use the force inside of factory IO, just not to have to control a lot of variables in our program. The other item are going to be these removers. And all these objects are is they get rid of unnecessary objects. As you can see right now, I have a bunch of boxes piled on. If I drag this to the remover, it's simply going to disappear. So it just makes our animation a little bit neater. It has no active environment in this case, but you can select many different objects depending on what's passing through these removers. And the last one is the chute. So the chute is just a stationary conveyor that's going to send the boxes downstream, so nothing really particular there. So when it comes to actual inputs and outputs, the only thing we need to take care of on the PLC side is going to be the sensor that is detecting the box right in front of the pivot, as well as the pivot arm. As I've said, we're only going to take care of the turn, so we can go back into file, into drivers. I've already pre-populated both of these signals, so that's going to be diffuse sensor 2 and pivot arm sorter 0 turn. Inside of my Studio 5000 PLC programming environment, you will notice that I have given my tags description. So the first one is going to be the input, which is the pivot arm sensor. So that's going to detect my box right before the pivot arm. And the second one is going to be the output to toggle the pivot arm, as you can see right here. So Boolean output 4, and that is the pivot arm. And when energized, it's going to turn for that box. If we go back to our program, so let's go back into Factory IO Sim, I can find the area in which we have figured out which size of a box this is going to be. And we can leverage this logic to create the counter, or essentially the FIFO logic, that will allow us to reject at the very end. So how can we get this done? Well, we're going to use an FFL instruction. So what I'm going to do here is I'm going to first of all assign an ID to each box. So I want to differentiate in a digital way what is the difference between my wide box and my narrow box. And in this case, all we're doing is counting them. So I'm going to assign arbitrary numbers in a real world environment. This could be an RFID tag that is read from a specific product. This could be a SKU number, and ultimately the possibilities are endless. So we're going to use a move instruction first of all. So MOV is going to be your instruction. And in this case, as I've said, I'm going to give this arbitrary numbers. So for the white box, this is going to be 2222, and I'm going to call this box ID, and I'm going to right click, create new box ID, and this is going to be a double integer inside of my tutorials. That is perfectly fine. And then the other box, so this is the narrow box, this is going to be simply 3333. Once again, whatever the double integer can hold, you can use any identification here. If you have maybe 10 different SKUs, if you have 100 or 1,000 different SKUs, this is where you would set the IDs. Now, once we detect that a specific box has passed through the initial set of photo eyes, we need to shift that ID into our FIFO, or first in, first out register. So as I said, I'm going to add a instruction below this, which is going to be the FFL. So I'm going to paste in an XIC, type in FFL, and let's quickly understand this instruction. So what this instruction does is it's going to send the box ID into an array in the order that they come in. So for example, my first box is going to be the white box. It's going to put in 2222. If my box again is a white box, it's going to add a second array type, and it's going to be 2222. So to program the instruction, you really need to either know what you are doing or you need to look inside of the help files. So again, if you right click any instruction inside of RSLogix or Studio 5000, you can select instruction help and learn more about that specific instruction. That being said, I'm going to walk you through the setup in this specific case. So the source, as I've said, we want to shift the box ID inside of the array. So I'm going to type in box array or box ID, which is going to take the double integer, which is the box ID, and it's going to put that into my FIFO, which in this case is going to be an array of double integers. So this is going to be box reject system, and I'm going to put the 0th element. So I'm going to right click, new box reject system, and I'm going to create, in this case, you can create as many as you would like. Remember that there is a cost to allocating an array in PLC systems. This is a fairly recent controller, so there's not a lot of harm if you can create this of, let's say, length 100. Even though we're not going to use all of those numbers, you can reduce it once you've seen the application. So I'm going to create that as a double integer of length 100. And next we have control. So control is just a very specific tag that's going to take care of all the background work of the FIFO. So in this case, I'm going to call this box reject system CTRL. Again, this is not something we'll need to mess with, but it will be used in the unload instruction. So I'm going to right click, new control, make sure that the data type is control. I'm going to click on create. In terms of length, again, here it's not going to matter because we're going to unload, but we can set it to 100 and position is going to be 0. There's going to be applications in which the length is going to matter. So pay attention in your specific application. In any case, everything looks good here. So I'm going to load this in and I'm going to compile my program. I want to see what happens as an example of this instruction. So what I'm going to do is I'm going to right click the box reject system. I'm going to click on monitor, and you'll notice that I have a number of double integers inside of an array. They go all the way from 0 to 99 because we've specified 100 of them. So you'll notice that the last one is going to be 99. So how do we make use of this? Well, if I go back to the first array and I play the animation, if I switch back into factory IO, I'm going to press play. I'm going to remove the force on this pivot arm. So instead of the belt, I want to make sure that I disable the turn. And what we should be getting at this stage is a set of box IDs captured by our sensors. So we obviously have not created a display in any way in factory IO. That being said, as the system is running, if I switch over to Studio 5000, you'll notice exactly what is going on. So you'll notice that I'm adding values to the end of my array as boxes go through them. And depending on which type of a box it is, it's writing either the 2,222 or the 3,333 box ID that we have specified inside of the FIFO load instruction. Now, the idea is that once the second sensor, which is at the turning point, is reached, we will be able to detect what kind of box that is without necessarily detecting, but by reading this array and then sorting the box accordingly. So let's look at how that can be done. So navigating back to our logic, when do we need to change the state of the pivot arm? And that's going to be when we detect a box at that second sensor. So remember, we have a tag now that is set for the second sensor. So I'm going to drag out a new rung underneath the FIFO load, and I'm going to drag out an XIC. Again, if you are lazy like me, you're going to control C, so control copy that XIC, and you're simply going to change the last number of that input, and you'll notice that it's not the right one because of my description. So I'm going to change that to a 4, and that is the pivot arm sensor, which is what we're looking for. So in order to, first of all, we want to do this only once. So I'm going to copy the one shot as well. I'm going to paste that in. You should only be using a single one shot once inside of your program. So I'm going to change this to a 1 in order to make sure of that. And if you're not paying attention, you can also right click and you can cross-reference this one shot to make sure that it is only used once inside of the program. I've seen many issues where programmers copy paste the one shots they've used, and that creates all kinds of weird behaviors. That being said, we have the one shot. Here we need to unload. So I'm going to copy this FFL. I'm going to paste that at the end, and I want to make that an FFU. So FIFO unload. And in this case, you'll notice that the FIFO and the destination remain the same, but we need to flip them around a little bit. So my destination is no longer going to be the array. I want to remove an element from my array. So I'm going to copy this and put that inside of the FIFO. And in the destination, I want to create a state for the box. So this is reject ID. And I'm going to essentially transfer the box ID from that array into my reject ID. So I'm going to right click. I'm going to create a new reject ID. This is going to be a double integer inside of my tutorial's subroutine. I'm going to click on create, and everything else should remain the same. Now, you may be wondering, how are we activating the pivot arm? And the answer is we are not. We need to still create the logic that's going to actuate the pivot arm. And so, depending on how you want to program your system, I typically would do this in a new rung. You can also do that as a branch around the unload, but we may want to use that logic for something else. So I do want to create a separate rung. So here, what I'm going to do is I'm going to do an equals. So an equals instruction allows me to compare a value of a double integer to another double integer. So in this case, if my box value is to 2, which remember is going to be my box ID for the white boxes, then I want to reject that. So here I'm going to type in reject ID, and I want to enable the pivot arm. So I'm going to copy one of these OTE instructions, and I need to find the right bit. Again, I don't remember all of them by heart. It should be number 4. And as you can see, based on my description, that is the pivot arm turn. And so if both of these are equal, I'm going to turn the pivot arm. And I'm just going to double check the cross-reference to make sure I don't have this anywhere else. I'm going to compile my program. Let's take a look at the result we have thus far. So if I start the animation, you'll notice that the boxes are going to roll down the conveyor. We're going to store those values inside of our FIFO array, and we're going to be detecting the type of box we have by the sensor. So notice that the white boxes are the ones that should activate the arm. So that is a white box. It's going to be shift to the container. Once again, this is a white box, so it's going to be shifted to the container. If it's a narrow box, the conveyor should remove itself, and the process is going to continue. Now, you might be wondering, what do we need to do in order to reset this? So there's a weird scenario. Factory IO is, once again, not representative of the real world. So if you want to go back to the logic, first of all, you want to clear the reject ID, and you want to reset your array position back to 0. So once it's reset back to 0, it is essentially considered empty, and it's going to repeat the process that we just looked at. So it's going to look at a specific position, and you need to make sure that you reset it if you're going to just simply restart the operation. Obviously, in a normal plant environment, you shouldn't need to reset the conveyors all the time. The boxes that will be stopped should go through the same photo eyes, so your system will be tracking. Now, what if you want to switch the boxes? What if you want to swap the lanes? Well, that's really simple. All we need to do is change the reject ID to 3333 to represent, once again, this is going to be the narrow boxes, so that's going to enable this time. And I'm going to double check that everything works as expected. Again, you can direct a number of different box IDs, and you can use as many flip turns as you would like for practice purposes. That being said, let's go back into our animation, press play, and see what kind of a result we get. So remember that we swapped to the white boxes now going straight and the narrow boxes going down this chute. So let's make sure that everything works as expected. The first box is reaching the sensor moment of truth. Everything looks good. And here we're going to have our first narrow box, which is going down this time. This one should go through. So our application is working exactly as expected. The FIFO instruction is not that complicated in RSLogix and Studio 5000 PLC programming. If you have any questions, you can always post them on the Solus PLC forums, and we will see you next time.